Today I will be talking about construction grammar, and this is a particular approach that has interested me for more than 50 years now. And every year I still learn new things about what a construction grammar is. As Guillaume already said, it's a family of approaches, and this has many advantages. We are very open to discussion, but at the same time, there is no real consensus about what is a construction, what is the fundamental data structure of this field. In order to understand what the potential is of such a construction grammar is, we have to look at how construction grammar evolved over time. So when we look when construction grammar emerged in linguistics, we are in the 1980s, and the mainstream approach was Chomsky linguistics, where a lot of focus was on what was called the core of language, which you can capture with very systematic rules, and everything that is not part of those systematic rules are periphery, like exceptions. The problem is everyone who works on Tao, natural language processing, knows that language is full of pockets of exceptions and sub-regularities, and so the periphery is actually much larger than the more systematic parts. And so out of frustration with this distinction, grew the idea that maybe what we find in traditional grammars, like this is a construction that we find in this language, that could actually be also the way a grammar is organized. So this was people like Chuck Fillmore who said construction grammar can be an approach where we have the whole of language. So not only the core, but also the periphery. And we don't give up on the idea of formal precision that Chomsky innovated in the 1950s and 60s. Now, whenever you have a new innovation, new technology, you tend to stick to what you know. And to make an analogy with theater and movie and cinema, first cinema films that were like theater that were filmed with like a static scene and all the other things. And it's only when cinema developed its own grammar, if you want, that the full potential is reached. And I think maybe construction grammar is already too old to compare it to old cinema, but we still haven't reached this place yet where we can do all kinds of stuff that was not possible before, when we had a distinction between, on the one hand, a lexicon, on the other hand, rules, and on the other hand, a periphery of exceptions. So the idea is that one data structure, a construction, can do all of that at the same time. So what I wanted to talk about today is at least, and maybe some more if I have time, is, you know, what are these constructions? I call it Fillmore's dangerous idea because I think it has the potential to completely flip upside down linguistics and applications in language technology. We'll illustrate that through argument structure constructions, which are like the most hotly debated topic within this family. And in order to do that, we'll have to chop down the syntactic tree, which linguists love so much. And the alternative is that constructions are no longer tree structures, but multi-dimensional structures. Let us start with the dangerous idea of Charles Fillmore. So what is a construction? Everyone has their own reading of the early construction grammar papers. There is one that I particularly like. This is a 1988, very short, very clear paper called The Mechanisms of Construction Grammar, where Chuck Fillmore lays down a couple of criteria what he believes is construction grammar. And I think that's a good basis to start from. Doesn't mean we have to stick to everything he wrote back then, because science evolves. But it's a good idea to understand where we come from. And so I think this is a very important quote. A construction is any syntactic pattern with whatever is linguistically conventionalized about it. So anything goes. And this is already a big challenge because we want to be formally precise. And I forgot who said it, but one of the critics of construction grammar said, that means this is linguistics on vacation. Right? If everything goes, how can you be systematic? The idea is we can be systematic. So one very famous example is the what's X doing Y construction. So you find patterns like this. You would find them typically in a traditional grammar. English has this expression, there is these semantics attached to it. And so in this 99 paper, they have all these examples, and they try to go in a very formally precise, systematic way to analyze what this construction is. So what's X, this Y, a girl like you, this house you, doing Y in soup in a place like this. So construction kind of, instead of distinguishing nicely the combinatory rules, which are like syntax, and the words, construction can have both words, can have partially filled in, can be partially schematic, partially abstract, can be very specific. And the way to do that is to, instead of cutting the cake horizontally, like linguistics has been doing, which is a very strange way of eating a cake, you cut the cake vertically and you have all of this information in one space. Those are constructions. And then the question arises, what's the difference between, let's say, a construction grammar and any grammar formalism that uses features like HPSG, things like that? So a very good question. And then this is one of the reasons why people working in HPSG have been very interested in figuring out whether they also can do construction grammar, which led to sign-based construction grammar. And so this is typically like these, schema that linguists draw in their analysis. On the one hand, you have form properties, and form should be seen as a very large thing. It's not just the sentence, it's also the morphological properties, the phonology. And then what is conventionalized about the meaning. And so we've been working on a computational implementation of construction grammar, not a theory, but a platform for developing construction grammars. And the abstraction that we believe is important is going from what is here formulation and comprehension. If I'm comprehending, I want to map from, text I'm reading or signs that I'm observing or sentences that I'm hearing. I want to translate that into meanings. But it doesn't have to be a neat separation between meaning and form. Whatever is already available for me in the form part, I can use while processing. And so I will come back to that later, why we do this in ECG like that. Now we're not finished with Fillmore's criteria. When Fillmore was developing, and his colleagues were developing construction grammar, phrase structure trees were still like the default way of doing syntactic analysis. And they conceived of construction as spanning parts of a tree, subtrees. But you could go any depth into the syntactic tree. So that's this criteria. A construction grammar doesn't have local between the parent and its daughter. So the phrase structure, context free grammar, you can access any depth. And again, we can ask ourselves, what's the difference between construction grammar and a formalism like tree adjoining grammar that can basically do the same thing? A very MacGyver solution. Constructions may overlap with each other, and this is, I think, that small thing that makes constructions different from what HPSG typically does and what tree adjoining grammars typically do. And we'll see examples of that. And then a more recent definition is that constructions can represent very simple configurations that you could equally capture with phrase structure trees, right? And a lot of confusion from other people, but even within the construction grammar community, comes from this idea that most constructions still represent these phrase structure trees. However, if you want to make it work, if you want construction grammar to be something that's not linguistics on vacation, you have to get rid of this particular assumption and go into a more complex data structure. And what you lose in simplicity of your basic building block for your grammar, you win in overall simplicity of the model. So constructions can be more complex, and it is particularly that kind of construction that we're interested in. Okay. Now that is very abstract, so we'll try to make it more concrete by working on an example that most people who work on construction grammar know, and what even people who are not construction grammarians will be familiar with, which is how construction grammar deals with argument structure combinations. And here is an example of the famous the way construction is kicking your way out of lexicalism. Is how can we get rid of the dominant lexicalist approach in linguistics. So to recap, a lexicalist approach means that you're going to define in the lexicon what the distributional potential is of a lexical item. So to laugh is an intransitive verb. You will say it only takes one argument, and then you can compose sentences like she laughed, but it would be ungrammatical to say she laughed a smile. Okay. Similarly for transitive verbs, to enjoy, subject and direct object. So intransitive uses a bit sketchy, but we can say we enjoyed each other's company. That is fine. And then you have ditransitive verbs, to offer, where you can say she offered him a yellow flower, meaning there's 3 arguments involved. Okay, so that's basically the heart of lexicalist approaches. And lexicalized grammars, they typically have a small set of combinatory rules. And I use categorical grammars as an example because I think they're the most pure example of lexicalist grammars, and because they're very powerful. So in a categorical grammar, you would say that determiner, its category is, it becomes an NP if it is followed by a noun. And a child is a noun, a book is a noun, and read becomes a sentence if it is preceded by a noun phrase and followed by a noun phrase. So that's basically saying that read is a transitive verb. So if you have a sentence, you can do bottom-up processing of these rules. You look up the categories that are combined with it. You apply this rule in any way you want. Here we do backward application. So this, together with this, eats this argument or consumes it and forms this category. And now if we do forward application, we build a sentence, and that's how, like in categorical grammar, in a simplified way, you build a tree. It's a very powerful idea and very successful for many, many applications. Now, the problems with these lexicalist approaches is that when you really take situated language serious, like embodiment and interacting with other people, you often have communication that is not confined to lexical boundaries. So in human-machine interaction, we see this immediately, but any expert on sign languages will also tell you that there's simultaneous signing going on in parallel, because the visual processing allows us to sign in parallel. And some of the signs will cover more than one we would call lexical boundaries. So how are you going to fit that into a nice lexical approach? Second drawback is that you have to kind of compositionally compose meaning, whereas we know that meaning is often more than the sum of the parts, right? So not meaning is compositional to a certain extent, but some meaning is holistic. And then you get a proliferation of lexical entries, because this is what L. Goldberg showed convincingly, is that the same verb can occur in multiple argument structures. So you have multiple argument realization. This is not exceptional, this is actually the rule. So most verbs do all kinds of things. And in lexicalist approach, you have to then find solutions to account for that. So either you have a basic lexical entry and then you try to apply lexical rules to change its valency, or you have multiple lexical constructions to account for that. Whereas the alternative that Adele proposed is much more starting from the viewpoint that language is situated, which no one can disagree with. We use language in a particular situation, like there's people online following now, but even that is some kind of connection. And reality, we don't really think about it because it's come so natural to us, but reality is so mind-bogglingly complex that we cannot talk about situations directly. There's just too many facts. Okay, you have to decide what is important, what do I want to communicate, and what should I obscure from this. And one very popular approach is to use frame semantics, which is another idea that originated among other people with Fillmore. is that if you have an activity like this, and what the woman in the picture is doing, you can kind of conceptualize that in different ways, but you can frame it as a baking event. And a baking event, you know, associates all kinds of encyclopedic and world knowledge that you have associated with that. Has different slots, like someone who does the baking, the food that's being baked, utensils being used, ingredients, the location where baking takes place. All of this knowledge is evoked by just using a word like to bake something. And that is, in my opinion, what a lexical construction does. It's like an interface with this world knowledge that you have. But language kind of makes an abstraction and decides what are we going to highlight in this case. I could say she's baking a cake, transitive construction. But if I would say she's baking in the kitchen and I don't emphasize what food she's baking, I'm still talking about the same event. Do I need a different lexical construction for that? Or does the grammar help me in solving that? And the argument structure constructions that Adele Goldberg proposed is kind of doing that. So you have semantic frames like this. The verb has all of this potential because it evokes all of these elements in your mind. And then argument structure constructions are these larger patterns that carry meaning and can select what they want or can even add meaning to that. For example, what is not in this definition of baking is a beneficiary. She might be baking the cake not for herself, but for someone else. Should we put that into the definition of the lexical verb bake? There's good reasons not to want to do that. So in that case, you want to have this larger pattern that can add this meaning. And it kind of looks like this. So for example, a caused motion construction is like a word in a sense that it maps semantics and syntax. It's just more abstract. Now, this is an abstract case. It maps a cause motion, a cause or some goal and some theme onto syntactic functions like subject, oblique, and object. And some of these roles are like obligatory. The construction requires the verb to supply these. But if the verb does not have that, then the larger construction can still, you know, add this information. And a very clear case of when this happens is when you have verb like to put that has all of the information that the construction would apply, and you can fuse the specific roles of a particular event, like the one who does the putting, the place where you put something, and then the stuff that you are putting down, all fused with these roles. Now that's a clear case because it's at least three roles provided by your, you know, frame semantics, three roles in the argument structure construction. But very famously, she also said you can put verbs like sneeze in this construction. Normally, sneeze is the typical example of an intransitive construction. You can say she sneezed the foam of the cappuccino, meaning that these two roles were not provided by the verb, but are provided by the situation I'm talking about. And because the grammatical construction carries meaning, expresses meaning, I can still fuse an intransitive verb or a traditionally intransitive verb into this larger construction, which we call coercion. And English speakers will understand what this means. Might be more difficult for non-native speakers, but English speakers will have no problem in accepting this productive use of the cause motion construction. Right. So this was all in 95. That's fine. A computer should make it, should survive. This was all in 95. And most people in construction grammar believe in this assumption. But there is a lot of debate on, okay, how does this work, right? These are diagrams, these are schemas. How do you make it work? And not just from outside of construction grammar, but also from inside of construction grammar. And since then, there has been like a numerous amount of papers that have been published based on what we call the lexicalist versus constructional debate. Now, first of all, a misunderstanding about the construction grammar approach is that everything is put in constructions. That's not in grammatical constructions, not true. Constructional approaches also have very richly specified lexicon. It's just that the grammatical constructions also are meaningful as opposed to just combinatory constructions. Now, to go into the matter of the debate, First of all, the lack of proper formalization, which is kind of used to be a valid criticism, because as soon as the Berkeley flavor of construction grammar took off and became popular, you had different flavors coming in, mostly cognitive construction grammars that shied away from the commitment to formal precision. So someone like Adele Goldberg will use her diagrams because they're easy to communicate, but will not work out the specific details. And so that leaves it's good for communication, but also leaves it open for criticism. Another criticism is like it generates, like what prevents the construction from saying he bragged her to sleep, which according to Paul Kay is not something that English speakers would say. Stefan Müller said it misses generalizations because in a lexicalist approach, a passive construction is a derivation of an active verb form. A derivation, I use the word derivation, Stefan would probably be a bit angry about me characterizing it like that. What it means is you have your basic lexical construction. There is a passive lexical rule that changes the valence so that it can be plugged into a passive. And so that's how they capture the alternation between different constructions. Whereas in a Goldbergian style, you would say that the passive construction is just a sister construction of the active construction existing on the same level. So there is no, it just depends on which semantics you want to express. And this is the interesting part that I want to discuss in more detail, is that Stefan Müller has this paper with, I think, is it Stefan Wexler? Where they say it's basically a phrasal approach, meaning it's like a syntax tree, more or less how Fillmore originally conceived of the constructions. And then you have this metaphor, if you have this tree, then your construction has to be plugged in. And then they show that doesn't work. Okay, if that is what you're doing, they tried this with generalized phrase structure grammar. They tried similar things with HPFG. It doesn't work. You need lexicalism. Okay, so we'll go through these criticisms one by one. And so, first of all, it says it lacks the proper formalization. Now, I totally disagree with that, because a lot of people working on construction grammar have been doing computational implementations. We have embodied construction grammar. We have dynamic construction grammar, which is done by Peter Fort-Dominé here in France. We have template construction grammar. And then we in Paris, we have developed a system which we call fluid construction grammar. So we have computational systems for implementing construction grammar. What does that mean? Well, as I said, language is situated. And instead of treating language like an autonomous module, we are in Paris with FCG, we're going to try to do a whole systems approach. Where if construction grammar, you could say this is like this part of a semiotic cycle between a producer and a comprehender. But both typically we start from building a world model and maintaining a world model. We are doing sensory motor processing. I'm perceiving people here. I'm hearing all kinds of sound. And I'm performing actions. And then I need to, as a producer, I need to conceptualize, which is planning what I'm going to say, because I want to reach a certain effect, mental effect or communicative effect in the addressee. And then your construction grammar, in a sense, is kind of deciding how to express your conceptualization. And the addressee has to, or the listener has to do everything in reverse, is starting from the utterance, start to comprehend, and interpret this back into the world so that it makes sense. Okay, so that's like a semiotic cycle. And it kind of is presented here like different steps and different systems. Now we know that all of these things are going on in parallel, right? So while I am speaking, I am already planning my next words, and I'm at the same time modeling the addressees by listening to myself and trying to correct as I go along. And also the listener is not just passively observing and trying to parse. You are actually trying to step into my shoes as a speaker and also trying to fill in the blanks when some things are not completely clear. So we try to model all of that and then see language not as some kind of autonomous module, but as one part of this whole cycle. And in experiments we did in the lab, we typically done this with robots. with a real-world environment, conceptualize building categories from the ground up, and it's based on that we start doing grammars. And so, for something like argument structure, what we did was we had a puppet theater with puppets playing all kinds of actions, events with each other, and that would form the basis for the kinds of argument structure constructions that Adele is talking about. Now, how does that work? We'll try to go into a bit more detail. So, I'm going to say that constructions are, you can see a grammar, you can compare it to a society of experts. And every construction is an expert in a particular thing, okay? And while we're implementing, I'm going to use some scaffolding because we cannot build a complex building in one go. I will explain what this means, but if every construction is an expert in something, they are like an autonomous entity, and they can interact with any other kind of construction. This is the free combination of constructions. So there is no top-down control mechanism that says how constructions should link with each other. The idea is that as long as two constructions are compatible with each other, they can be combined with each other, right? There is no constraints apart from that. So for argument structure, if, let's say, the structure of a sentence is like a complex structure, like a building, right? And the building has its structural load, but it also has its heating, it has the electricity system, it has the plumbing, right? Now, the people who build buildings, they don't have to care about everything. So a verb could be somebody like an electrical engineer who comes and installs certain supplies, right? And an argument structure construction is an expert in knowing how these things then should be hooked up with each other. Okay, so if an argument structure construction says, if you can provide me with an entry for the water, I know how to hook it up to making a shower and things like that. MEP stands for mechanical, electrical, and plumbing engineer, right? Now, they have their preferences in how rooms should be organized in the building. You don't want your water supply to be far away from the bathroom, but generally they leave the structural load questions over to somebody who's an expert in that, right? So they don't necessarily always have to worry about all of the information in a sentence. So making that more concrete, here you see an example of how a construction looks like in fluid construction grammar. And on this side of the arrow, this is what we call the conditional part, because there is something that will trigger a construction. And that depends on the direction that we're processing. If I'm the producer, I will go from a meaning. I want to express a sneeze event. A sneeze event, I'm just using a first order logic representation here, as one argument, x, and everything you see with the question mark is a variable. So we have to bind it to a referent in the world. X will, for example, be bound. If I sneeze now, I will be X, right? If I want to express that meaning, this construction says, well, I know which word can be attached to that. It's the word sneeze. So that is like triggering in production this construction. And then there is a contributing part, which the construction can always add to the information that I'm processing about the sentence. So it could say, well, it's a verb. Its argument structure has at minimum one role. I don't know what the referent is yet, so that's all variables. I don't know what it will agree with in the sentence. That's not what the verb is supposed to know. Other constructions will deal with that. So it leaves all of these questions open. And if an argument structure construction, and let's say this is simplified clause motion construction, that says I will need a verb, I will need a subject, an object, and an oblique. Now, these are not necessarily already identified, but the combination will identify these things. So the subject corresponds to this box. Let's say it has to be a noun. The oblique corresponds to this. We'll have to start with the category. The object here, also a noun. And I want a verb. And the functional structure of the verb should, let's say I'm comprehending I should have a subject and an object. The argument structure construction. The argument structure of the verb should at minimum contain one role, which, and I'm using this variable x in 3 positions here. By reusing the same variable name, the construction is kind of saying these should point to the same reference, right? If you bind them to some object in the world, it has to be the same reference. If that doesn't work, then I don't want to apply. Now, it doesn't say anything about y and z in the same logs, meaning that the verb doesn't have to supply this information. It could, but it doesn't have to. If that's the case, then this verb can actually add those roles to the argument structure of the verb. If they would already be in the verb, it would just merge them in and fuse them together. If they're not there present, the construction will add it. Okay. But this, by splitting up what triggers the construction and what a construction can contribute, which is basically what Goldberg says, you can make this conversion happen. Okay, so we know how this works, and we don't even have to have the same symbols like theme and goal and a causer. How does that map onto sneeze, the sneezer, and the other roles? Well, this is what Goldberg calls fusion, and fusion is something that we can do with thematic fit. Okay, we can either, if you have a real world model, you can go into the world because a symbol is always just a pointer to some big structure, right? A lot of criticism on feature structure grammars is that how can it be as complex as the real world? Well, a symbol is only a pointer to a big structure that you have learned while interacting with the world. So a causer is a complex prototype that you can flexibly match with something. So when you have something like putter and put place and putty, right? These are specific ones, but they will fit with a certain extent into these slots, and you can figure out on the fly what the best fit is. And so that's how fusion can work. Okay. If we have time, I can show some examples in real time how that works. Let's say that it lacks proper formalization. That's a solved problem. We know how to implement construction grammars. It took us some time, but by 2012 we had a very stable formalism, and in between 2012 and now, the last 10 years, we have built construction grammars that are broad coverage, that do that can be applied to real world problems. So we know we have proper formalization. So that criticism just isn't valid. It's not linguistics on holiday. A construction can be implemented. Okay, constructional approach overgenerates. Second issue, you drag that to sleep. Again, let's think about the semiotic cycle, right? In a semiotic cycle, the role of the grammar is no longer to be a generative grammar. A generative grammar is a grammar that can, depending on how you implement it. So if you're more of a Chomskyan generative grammarian, your grammar will produce structures. We'll try to find a structure that is compatible with the sentence that you're parsing. If you're more into the constraint-based approaches, you will check all of the constraints to see whether your sentence didn't violate any constraints. The idea is the same. The whole space of grammatical sentences is supposed to be captured by the grammar. Why? Because the grammar is an autonomous module. It's still a thing that we carry along from the Chomskyan era. In cognitive linguistics, we look at the whole cycle, and the grammar is not a generative system that autonomously has to decide whether a structure is correct or not. It expresses conceptualizations. So if I don't conceptualize bragging as a cause motion event, the grammar will just simply not produce it, because it tries to translate my conceptualizations into a sentence. If I want my grammar to be as flexible as possible and do it for me. Similarly, when we have productive uses in a corpus and we see a coercion happening, well, we cannot foresee every coercion event in the grammar. I want my grammar to be as flexible as possible. On top of that, every successful language technology these days is probabilistic and will assign probabilities to what the best analysis is. So you want to have this big space of possibilities to get to as much meaning of a sentence as you can get. And if you have a novel meaning that you conceptualize, or you want to be a bit more creative, you still want to be sufficiently conventional in your creativity that somebody who knows the rules of English immediately understands what you say. So you're inviting your addressee to use brag as a past motion verb in that instance. So I don't think that this is a big problem, but even if you would want to have a construction grammar from a generative point of view, which some people do, so first of all, I said coercion is functionally motivated. Here in Paris, here I look again at the metaphor of the plumbing and electricity and things like that. They're supposed to be hidden in the walls. At the Centre Pompidou, they're put right outside. It's not supposed to be like that. It's not conventional, but it is functional. For example, you gain a lot of space inside of the building by putting it outside. And it's a museum of modern art, so, you know, why not? It's functionally motivated. So we can violate the constraints because it's interesting. Language works in kind of the same way. It's a cultural product. But even if, let's say, we want to have a generative construction grammar, then you can do what Goldberg calls statistical preemption, meaning that if you have two potential constructions competing with each other for expressing a certain thing, if I use one construction, if I observe the use of one construction with a particular meaning, I will simultaneously dampen my preference for the competing constructions. That's what she calls statistical preemption. We call that lateral inhibition in our research, but it's the same idea. Now, statistical preemption has been criticized by certain people. For example, entrenchment. Ben Ambridge says entrenchment is a simpler mechanism. It's true, but we tried this in models, it doesn't work. Right? Entrenchment just makes the more frequent constructions always win out. That's not what you want. You need to have local, maxima that allows a construction to say, this is my domain. People like Charles Yang said that statistical preemption is computationally too expensive, which is just not true. We use it in all of our experiments. One model that we did was on, we call it alignment or lateral inhibition. So if you're communicating, and remember, we are working with robots or artificial agents, they don't necessarily know the conventions yet. How can they learn these conventions? Well, they use constructions in a successful interaction. So it's always based on community success. They will increase the preference score they have for a particular construction, but then decrease the score of all its competitors. So an example, if I'm learning French, and I think that girl could be a French word, and so if I'm learning English and I know fille, and I hear now girl used for this meaning for the first time, both have the same score, a value between 0 and 1. I'm going to update my confidence that this is the association that is most conventional in my speech community, and I will punish at the same time the competitor. And what this does, it gives you this S-shaped curve that we observe in language change, that at some point, one of these two, it has a gets richer dynamic and becomes the convention. And this has been observed for very artificial experiments with Andrea Baroncelli, for example. They did this for naming conventions, but also confirmed in historical data by people like Richard Blythe and Bill Croft. They always see this S-shaped curve kind of happening. So this idea of statistical preemption or alignment or lateral inhibition, how you want to call it, it fits with the data that we know, and it works in agent-based modeling. So overgeneration is really not an issue for us. It's really only an issue if you want to work in a generative grammar paradigm, and even then, there's ways to solve it. Next criticism, constructional approach misses important generalizations such as the active versus passive alternation. Okay, there is a lot of hidden assumptions in this criticism. The assumption meaning that these constructions have a particular relation that is very important. And there is obviously some relation between the active and the passive. But in construction grammar, this is what Adele Goldberg calls the surface generalization hypothesis. is that often we can learn more about a construction by looking at the construction itself and what it's doing. And so we have good empirical reasons to believe that the passive construction is a construction that has its own semantics, right? You can look at all the verbs and see if, for example, active would be the most basic construction and passive would be followed by a lexical rule. Your prediction would be that most verbs, if not all, would be more frequently active than passive, which is just not true. For example, to be born, for example, the verb to bore in English is almost never used anymore in an active. You say she gave birth. You don't say anymore she bore a son, or very rarely. You would use this verb almost exclusively in a passive construction. And so you can predict verbs that have more lexical semantics that emphasize the undergoer, what the passive construction is expressing, tend to occur in a passive construction, right? So there's good empirical reasons to believe that those are alternative constructions. So that is one thing. But the second thing is, what is, again, the assumption, what is the goal of your grammar? And somebody like Stefan Müller, who posed this criticism, one of the goals is to be as general and concise as possible in your description. Now, somebody like Edel Goldberg wants to have a psychological plausible model. And so you could say ALO. So if we miss it, what's, in our mind, we have so much redundancy. I'm trying to model what's going on in the mind. And so the redundancy is just part of language. But even if you insist, again, ALO is not a strong response. Even if you insist that there should be some kind of relation, then you can make constructions work together in such a way that you have the same generalization in your grammar. So if you have an intransitive construction, for example, and you have a construction that has the added path construction, this is actually a proposal that Paul Kay did at the moment, at some point. You can indeed combine them to form on the fly these cost motion constructions. And then depending on how general you want your inventory to be, you can redundantly store them, or you build them on the fly every time. So in that, if you do this, then the lexicalist or the constructionalist approach is just different notations for the same thing. Okay, the fact that you're doing construction grammar doesn't prevent you from implementing a lexicalist analysis. Okay, that is your theory. Construction is a data structure that just allows you to express all of these different things, and it's up to you, the linguist, to figure out what fits my analysis best. And then I think we come to the most interesting criticism, is that the constructional account is actually a phrasal or a plugging approach, and that we know after 75 years of research that just doesn't work. Okay, so again, this assumes a lot. This assumes that constructions are phrasal constructions, like in phrase structure trees, which used to be the case in the 1980s, but most construction grammarians would now shy away from this commitment to phrase structure. And even Goldberg herself said they are phrasal in the sense that they have more than one word, but they do not necessarily assume to be phrase structural. Okay, but you don't have to be necessarily a syntax tree. Now this makes a big claim, and then we come back to the question: if not a syntax tree, what is the structure of a construction? In order to do that, we step to the next part. We have to chop down the syntax tree. And if you allow me a small digression into history of linguistics, it's often said that there's a saying that says if a butterfly flaps its wings in the Amazonian rainforest, then a tornado will form in Texas. And this more or less happened in the 1950s. There was a butterfly named Noam Chomsky. He made some assumptions that were very logical at the time, but that keeps getting repeated like legacy in linguistics, even in construction grammar, that officially breaks from this tradition. So without even realizing it, a lot of constructional analyses are just putting on a new jacket for an old analysis. So this is actually a pattern that we find in linguistics, not just with Chomsky, but in linguistics is generally a pedigree-based field where if somebody has sufficient authority and no greater authority in a particular part of the field than Chomsky, then people follow this. Innovations that Chomsky introduced became increasingly normative without anyone really thinking about it. And then they become standard practice and nobody questions them anymore. Okay, so our butterfly flaps its wings one time. So Chomsky, and it's a pleasure to read syntactic structures. It's a very marvelous piece of writing in how rhetorically he makes certain assumptions. So syntax is autonomous. Why? Well, colorless green ideas sleep furiously. We can say in some way that this sentence is more English than furiously sleep ideas green colorless. Okay, so there's one particular sentence why Chomsky said it means that syntax must work, independently from semantics. Consequence is the assumption that we can study grammar like a formal system, idealized that generates all and only of the well-formed sentences of a language, and rejects the ungrammatical sentence. Now, just a side note that the people listening who work on natural language processing will know that even a simple statistical parser will give a higher probability score to the first sentence than to the second one, right? So just because these continuations are more probable than what you see here. But that aside, so this shows that Chomsky, which is normally in the 1950s, by the way, Chomsky wasn't sufficiently aware of what probabilistic language models would be able to do. But the second assumption is that Chomsky worked not on tree structures but on strings. So the grammar had to generate strings. Now he just took what was the most popular analysis at the time, which was immediate constituent analysis, and he asked himself, what kind of grammar would be able to generate those kinds of analysis? And he came up with phrase structured grammars. And because he was working on strings, there is automatically this assumption that everything has to be continuous, right? Cannot be discontinuous. So you can rewrite a symbol S as NP and VP, which are right next to each other. You can rewrite it like that. And so you get into a derivation that nicely produces your linear string. However, linguists before Chomsky wouldn't think about tree structures like that. So this is one example where discontinuity is allowed. You have examples like this. Find sentences like that. So immediate constituent analysis wasn't necessarily continuous. It was discontinuous constituents as well. And somehow, phrase structure grammars and almost all of the phrase structure grammars developed since then keep this assumption of one parent node, immediate children, and continuous. So immediate dominance, linear string. So we can produce a nice sentence. So the grammar generates strings, and the tree was only seen as a side effect of it was kind of thrown away. This was more interesting than derivation. But the consequences is that if you only care about generating a string, then you only need one kind of rule mechanism. In this case, it was phrase structure, and they have to conform to the linear order. Okay, so everything that we had in Europe, basically from functional grammars with the different layers, information structure, functional structure, things like that, they become like secondary class citizens in this kind of approach, and they have to be, attached to the basic rule mechanism of phrase structure. We have now single dominance continuous constituents that end up. And then, of course, there is a famous chapter where Chomsky shows that these phrase structure grammars are not capable of generating all of the sentences of English, or they can only do it very clumsily, which is why he distinguished between the base component, which is phrase structure, and then transformations that worked on top of that. And then a lot of people started questioning transformations at some point, but never questioned the duality between this idea of a kernel versus surface structure. you still have in many analyses the idea that there is a basic structure, and then you have all kinds of mechanisms like lexical rules, feature passing, feature percolation, that try to go from this basic structure and then add things to make it fit with a surface tree. So linguistics went from describing this to describing this. And that is one thing that people who work with computational models and formal grammars have to be modest about, is that we want to approach this, but usually we have to make some sacrifices in what we are capable of modeling at the time. And there is always some part of left to empirical research that we have to be aware that this exists. It also means that there is this legacy. Now, a legacy software, there's a nice anecdote. Windows went from version 8 to number 10 without going to number 9. And rumor has it, it's not been confirmed, but rumor has it that it becomes because there is software, third-party developers have software that check for the version of Windows. And they're check for whether something is Windows 95 or 98 is whether it starts with number 9. All of that software would break down if it would be Windows 9. So they said, let's not do it, we immediately go to 10. Okay, so that's an example of legacy software. In order to backwards compatibility, you have to do all kinds of tricks. And in construction grammar, there's too much legacy that is still being carried on from generative grammar. So what is this storm then? Well, the focus on strings was an historical accident. James Macaulay said that the people, Chomsky and his colleagues, were more familiar with string theory than with trees and this tree structure. So they actually started solving this problem and now work with tree configurations. So Macaulay reinterpreted these phrase structure rules as constraints on tree nodes, which is still being used in, for example, sign-based construction grammar. A construction in sign-based construction grammar is sets of constraints on mother and daughter relations in the tree. Nevertheless, all of the primitives of the tree structures, they remain in place. So immediate single dominance, continuous constituents. And these problems, they were well known already in the 80s. Models like lexical functional grammar, this is one of the reasons why they said we want to have functional structure on top next to our phrase structure grammar, because this tree structure is doing too much. We have to hang everything into this tree. The second thing is, of course, it turns out that semantics is relevant for speakers' ideas about well-formed structures. This is, I believe, the second law of computational linguistics. Semantics always messes with your system. And so you need to smuggle in semantics in some way, but instead of, again, rethinking the basic structure, you kind of try to attach these functions, which were first-class citizens in traditional grammars, you reinterpret them as syntactic prepositions. So that's why when they say the object should be in the immediate domain of the verb, that's because you assume there's a verb phrase and the object is supposed to be here. Now, when you have a sentence like, what did the linguist analyze? What is somewhere up here, not in the immediate structure, if this is your assumption. So then you have to solve this problem where something is missing here, which is called a gap. You percolate information or you do transformations until you find a filler for that gap, because you assume it should be here. This is the position where it is interpreted. Again, these transformations, they were rejected on empirical and formal grounds by some part of the community. There are still transformational grammars like minimalism that also do serious work on formalizing their stuff. For example, there is minimalist grammars by Stabler. But people who rejected the transformations, they kept the idea of basic patterns versus more topical patterns. So this is the this is, for example, a filler gap analysis like HPSG style Ivan Sag would propose, is that hit normally is a verb which has two arguments in its valence, there is a lexical rule that identifies a gap that takes away the one of the valence, puts it into a gap, and then you add information, you percolate that information up. So how that works is there's a combinatory rule that consumes first of all the valence. So this is put into a verb phrase. Combined with the noun phrase consumes the valence. Valence becomes empty, so we have reached an S node, but there is still a gap that is unfilled. And then that information is percolated up, and then here you have the NP with the same index as here. So this part of the structure and the feature gap are all kinds of tricks you have to do because you assume a fixed position for your subject and object to be in. And this kind of analysis you find still in constructional analysis. So there's many habits of the generative grammar paradigm that we moved over to construction grammar without empirical motivation. And this is something we have to shake off. Okay? And we cannot reach the full potential of construction grammar if we're just doing the same analysis over and over again. So what is the constructional alternative? Again, I like this building metaphor because a building is a complex structure. And if an architect wants to make the blueprint of a building, this is what grammarians do. They make a model that describes a real-world object, so the knowledge that we have about the language. You cannot put all information about a building on a single blueprint. If you have a top-down view, you can see, for example, where are the windows located, but you cannot say at which elevation they are, right? You need a different perspective for that. But they typically have all these different perspectives. And a similar thing is that a sentence structure and even larger discourse structure is so complex that you cannot have one single view on that. The typical discussion you see is, should we use phrase structure or dependency structure, right? Now, this is the box notation of, or a simplified version of a box notation that Berkeley construction grammar would use. And the idea was that you can have nested boxes because you can go as deep as you want. Now, this is just a different way of drawing a tree because this is your parent node. And these are your immediate children, right? So you build a tree, but you just draw it differently. Why? Because it's useful to have the box to write down features, okay? And so that's how you would do a determinate noun construction from a phrase structure perspective. Then there is, there have been discussions, again, when the criticism of phrasal constructions came, there was a paper in Cognition that proposed maybe constructions are dependency structures. And again, box notation, the outward box is then your head, and this could be your noun, and the inner box could be the dependent, that's your determiner. And so it leads itself naturally to this kind of thing. The constructions can have both. Why choose between them, right? Here is again an FCG construction where instead of committing ourselves to a particular structure, is we're going to treat the structure as a feature, just like all the other features. We are going to describe it because we know from typological research that phrase structure, for example, isn't universal. Not all languages have phrase structure relation, or they might have only primitive phrase structure relation. And so your formalism should be able to do all of that. And so, for example, phrase structure can be captured by feature constituents that then points by using the names of those spaces in your structure. So it points to parts of your structure where it can find this information. So it points to determiner, it points to the noun. But the noun itself might have a dependence feature and represent the dependency structure of a sentence. And it actually points to the determiner. And so when we visualize this stuff, these are just lists of units. Units are like groups, regions in a network, if you want. They group together. It's like a box in which you put features. Everything that I know about the word lion is put into this box. Everything I know about my determiner is put into this box. Then, because it's so complex, we need to visualize it different ways. So sometimes I will switch back and forth between visualizing it as a noun phrase and visualizing it as a dependency structure. And if I can quickly get out of the presentation and show it in real time. So if you have let's say this sentence, short. We go to the FCG web interface. So this is the phrase structure view on that sentence. The order doesn't matter of the units, but you have your traditional S, you have your verb phrase, you have your noun phrase. These are all boxes, you can open them up. So you have all of the feature information. But sometimes I want to have the dependency structure and I click on a different view. Now you see I have access to the dependency structure, but they're all in the same, we call it transient structure because it evolves as the search space evolves. Why is this important? It's because a construction has to be able to access any information at any given time. And you don't want to traverse the whole tree every time to find information. So by having these different perspectives, at least phrasal structures, dependency structures, a construction has different entry points or different paths it can take into this complex space of grammatical structure. And a construction can actually just say, okay, I have a verb phrase, give me the head verb of this verb phrase, so it accesses the phrase structure. And now I want a functional structure of the verb, so what are the dependents? The subjects, objects, and it takes a different path and combines all of these perspectives in the same structure. And this allows you then to make the construction, which has this incredible expressive power, still be very concise and readable for a human expert. Right, so if you have multidimensional constructions, then you can easily do clause internal freedom, meaning we can easily swap parts of a clause. But can we also cross clausal boundaries, like it is a Fabergé egg that the Tsar gave his wife? And for this, I hope the movie still works. For this, I drew inspiration from Inception, the movie. So if you've seen the movie, it's really nice. You see there is, at the end of the street, it looks far away. But if you have a multidimensional structure, there's other ways of holding the space. And in one dimension, something may look far away, but in another dimension, it may be just right next to you. To give you an example based with my COVID mask here, is based on this surface dimension. These are two outer points. But if my space is folded like this, what looks like far away in one dimension are just connecting dots in another dimension. If you have these multiple dimensions, then information access is easy. And that is what constructions can do. And that is why you have to get rid of this very rigid tree structure and go more for a graph structure that can have all these dimensions represented in the same time. It's still a graph. A tree is a graph. It's just a more powerful graph. And that's why we come up again with the idea of Mirjam Fried and Jan-Ulla Ostman, is that it's especially these constructions that make construction grammar different than what other grammars did before. And it allows us to throw away so many concepts like the distinction between the vocabulary and the grammar can all be constructions. And constructions can still specialize in certain domains. Some constructions are more in the phrasal domain, other constructions are more in the information structure domain. But if they want, they can access any information. So they decide what information and how much of it they want to use. And you can imagine, and you just go back to all of the functional linguistics approaches, like Semantics functional grammar or systemic functional grammar. They all had these different layers. They had the event structure, they had argument structure, they had functional structure, but they were all in different layers. Then you have to build interfaces between these layers. The advantage of construction grammar is that all these layers are in the same data structure, so you don't have to build these interfaces. So here is just a diagram. If you have a sentence like the linguist analyzed the utterance, you can have at the same time the phrase structure. At the same time, you have the dependency structure, and you have the argument structure. All of these perspectives can be present in the same sentence, which means that if you have a different utterance type, often you'll have the same constructions that have been implied in building that utterance, but just the utterance itself is almost like a trace, a side effect of combining these constructions with different constructions. So the combination, as long as these constructions are compatible with each other, they will be able to match. And the result might be a very different utterance from the outward, but the same, this is what the surface generalization hypothesis predicts, the same constructions could be underlying it, leading then the option to then chunk that and make a more specific construction. So all of these criticisms, I think they are invalid because they start from theoretical assumptions that we drag along since the 1950s and that we can just let go of. The conclusion for this part of argument structure is that this cannot work is invalid. We have computational models. We just need to examine again, what are our tools? Why do most linguists still use these phrase structure analysis when they analyze a sentence? And there we see is if it gets too complicated to express that in your formalism, it means your formalism should be adapted and not your analysis. Okay, don't put the formalism in the driver's seat. You are the linguist, you are the expert. You have to be able to express your analysis. And the formalism is there to make that explicit and to show what are the hidden consequences. Another thing that might be interesting is that constructions are so powerful as a data structure, you can do anything with constructions, basically, is that they can be framework free in the sense that before the Chomsky revolution, theoretical descriptive linguists would just, describe the construction of a language. And then you had these formal grammars that were so different from the kinds of constructions that you saw in traditional grammars that there has been a gap and a tension between descriptive linguistics and theoretical linguistics ever since. But if constructions actually can do the whole grammar, then this kind of mental grammar, the representation of our mental knowledge, resembles much more what descriptive linguists have been describing in their work. So it kind of bridges, again, two different fields that have been separated for a long time. Now, if I still have some time, I would like to also say a few words about constructions in motion, because all of this is very theoretical. As I said from the beginning, when we started doing this work, we were actually not thinking about doing construction grammar. We wanted to investigate how a population of autonomous agents or robots could invent their own language with human-like properties. We had to develop a system for that later on we discovered was also a good formalism to do construction grammar, which is why we called it construction. I think it adds a new perspective, could add a new perspective to what linguists are doing. So these are stereotypical views that linguists can use based on which methodology you have. So the typical theorist view is very much based on idealizing an individual and the individual's competence in a particular language. Empirical and corpus linguists will typically look at population level and try to find what are the patterns that we have. And there is, and both perspectives are really important, but there is a gap between, let's say, what somebody who works on the mental view is doing, whereas a corpus linguist looks at the empirical behavior of people. And I think this kind of agent-based modeling that we do can provide some kind of closing the gap by modeling the dynamics of how these different shapes are formed. And so what you see here, these are, I think, sparrows. And it's fantastic because it's self-organized. Self-organized means that there is no leader sparrow. It says, now we fly left and now we fly right. These are split-second decisions, and all the shapes that you see are spontaneously formed. Right? There's no central control. And our approach is basically the same, is where do linguistic conventions come from? And it's mind-boggling that this is not a major question in linguistics. How is it possible that we can agree on what words mean and what constructions to use without ever explicitly saying how we should do that? You know, my apologies to the Académie Française, but French is doing fine and evolving on its own without the Académie saying how it should go or how it should be. I think the last funny example I had was the gender of the word COVID. I think most people will say le COVID, whereas the Académie has proposed it should be la COVID. But most people just don't care about it. It evolves naturally. Now, how much design do you need to get complexity like you find in natural languages? So could some structure like this ever be spontaneously formed? Well, with these processes that we find in nature, see, this is like a termite mound. There's not an architect among these termites who has a blueprint. This is spontaneously formed as a side effect of all kinds of internal functions. And in the same way, we are doing these experiments where agents start without any kind of agreement on which conventions to use. But by interacting, they are developing categories and structures for communication. And if there is some time left, I will skip to a different slideshow. I think it was this one. Yes. Different slides. Now, what is first, before I'm going to go into these slides, what does this have to do with construction grammar? Well, construction, because every construction is like an autonomous expert. It can be combined with any other construction as long as it's compatible. So we don't need, like in a tight constraint-based grammar, a feature hierarchy and saying how the construction should be combined. You learn the construction and it will find a way to fit in the rest of the inventory, which is also very useful for modeling dialectal variation or grammaticalization processes. And so I did this, I tried to test. But, when I was in secondary school, I struggled a lot with German, which is, I had a lot of difficulties passing my exams. So I was very relieved when some intellectual like Mark Twain said that this is an awful language, just no system, and slippery, elusive to the grasp. And this is, for example, the old High German demonstratives paradigm. So it distinguishes between nominative, accusative, dative, and genitive, singular masculine, feminine, neuter, and plural masculine, feminine, and neuter. Now, what's interesting is that there were twice as many demonstratives as there are definite articles left that evolved from this, which has lots of syncretism. So you see this, everything you see now in red are syncretisms that came from it. And syncretisms are interesting because it goes against my assumption. It seems at first sight, it goes against my assumption that language should be explicit and good for communication. And so why do all these ambiguous forms, what do they do here? And again, if you would look at these forms, like from a compositional point of view, in a lexicalist point of view, you do not see how they relate to other parts in the same argument structure construction. And so I put this to the test, right? So this is the current paradigm. I put this to the test. I took an artificial agent. One of them I gave, so I implemented a partial grammar for German. One population of agents, I gave them the old High German system, and a new population, I gave this system, and then I compared how do they fare in their work. So a lot of linguists, by the way, think that these syncretisms are just historical accidents, right? It's sound loss. It happened. Now we're stuck with it, but which is fine because I'm not good at German. But at the same time, how could for 1,000 years German speakers be okay with this system if it's supposedly not very good for communication? So I reconstructed all of these things. And I looked at particular measures, try to measure complexity. And so I made a distinction between what I call Q reliability and disambiguation power. Q reliability is you look at one particular feature in a sentence, how reliable is that for helping you to disambiguate something? So for example, if you want to know whether the subject is singular or plural, an antelope, it's the indefinite article, gives it away. It's singular. The man, it's not the article that gives it away, but the singular form of man. So we know it's singular. The fish, neither the article nor the noun gives it away, but the agreement with the verb is plural, so we know. The antelope ran, we still don't know it. Actually, we have to figure out that it's plural when we find the pronoun here. And sometimes the language just doesn't say it, right? Now, disambiguation power is looking at all of these cues in a sentence at the same time. And so can the sentence as a whole disambiguate these things? And so that's a distinction. So which parts of the sentence are responsible for disambiguating what information? Now, the interesting thing is that if you would just look at the top here, in black you see Old High German. If you look at these forms in isolation, of course, there were twice as many demonstratives than there are definite articles. Of course, the Q reliability of the old system was better, but take into account all of the other cues that the German grammar offers you, and there is virtually no distinction anymore, right? So there was clearly some redundancy. And from all of the remaining ambiguities in Old High German, they were plural distinctions. They all disappeared. Why? Because it doesn't really matter in the plural. The second thing was processing efficiency. Surely, ambiguity leads you to a lot of uncertainty in processing, but that depends a bit on how you represent grammatical information. So if you write things down like here, these curly brackets means that you have a choice to make. And this is what happens if you think that a competence grammar is completely separate from processing. You say, I don't care about how the processor solves this problem. I know these are the options. Then actually your processing model has to do all of the heavy work. And if that processing model is not very informed, even for a simple sentence, you get this is a tree structure with red all of bad solutions until you find a good solution. And this is just untenable for scaling up. Whereas if the grammatical constructions that offer a little bit more information, for example, having these paradigmatic oppositions, if you allow that to be taken into account during processing, the same explosion of combinatorial explosion in search disappears, and you have ambiguities when the language remains ambiguous. So processing efficiency is also not a problem. You could even say that the new High German system is more efficient because it only has 6 forms instead of 12, so you have to check less cells in your paradigm. So if we assume that instead of having atomic values, the value of a case feature in German is an array of 3 different values, and then you start filling in, it's like a blackboard. Right? The construction says, I'm a blackboard, give me information. So everything with a question mark is a variable. It's like, I don't know yet. But if I have there, then I know it cannot be this. Everything is minus, cannot be. You just leave the 2 slots open that can still be filled in. Now, can only be feminine, singular. Unifying these 2 will leave you only this slot as a possibility. So just combining these without creating search space, the construction disambiguates already what happened. And then we look at ease of articulation. That's just like, forms in modern High German, they're shorter, so they're easier to pronounce. You take all of these features and then you just do a simple minimal edit distance. How much of these values do I have to change to go to the next sound? And so D and das
And then you can see the numbers are too small, but you would see that the old High German systems, because they're longer, take a little bit more effort to pronounce. You can also think from the viewpoint of distinctiveness from the listener's point of view. And then you look at how distinct are these in terms of their phonemic features. And D and Das are obviously quite distinct and easier to distinguish. But D and dir, for example, are very close and more difficult to distinguish. And so, for example, if you take deu from Old High German, then these are the distances to the other ones. You see that diu and deo are quite close, but then den and demo, they're a bit further. When you look at the collapses of the system, in the New High German system, you see that from there, the distances are much more symmetrical. In some cases, where you would have expected some collapses to happen, it didn't, and you end up with a worse system from a distinguishing point of view. But those are the distinctions that would have caused ambiguity problems if they would have collapsed. So you can kind of look at the disambiguation power to predict which forms were likely to collapse and which weren't. So when you look at this from that perspective, it's like there is a plateau of solutions, and this gives a better view, is that in terms of these measures, the Old High German system was performing pretty well. Linguistic fitness is like a combination of all of these measures, but the New High German system was slightly better. And so the evolution is like motivated from a communicative and processing point of view. And it's not an awful system at all. Now, because evolution is blind, there is a better solution possible. And lots of German dialects actually only have a 2-case system there. Now, similar, I mentioned already sign language. Sign language is a societal challenge. 5% of the world population has disabling hearing impairment. And this is also a technological challenge because all language technologies that have been developed until quite recently and still today, they are biased towards the sequential streams of information from text and from speech. And so there is currently no real bidirectional models, meaning that we can both produce and comprehend sign languages very, very well, even though lots of advances have been made. One of the reasons why it's so difficult is, of course, there's iconicity. So if this is in French sign language, the symbol for ball, a big ball, you make the ball bigger. And so systems are quite good at recognizing signs in their citation form, in their dictionary form. But while signing, this gets very complex fast with all kinds of parameters and really difficult and very nice system. So this also the challenge of co-articulation, multiple signs handling at the same time. So for example, French Sign Language has a different way of organizing things than French, of course. Car, you have a sign, I don't exactly know what the sign is, but then it's a classifier. You introduce the child referent here, the classifier is still present, so you have a co-articulation of both. And then actually you depict a moving towards the other classifying, like moving the child towards the car that you classified here. And that is something you cannot put in a tree structure. So all of these things, facial expressions, shoulder and head movements, use of 3D space, all of that is very difficult to capture in the traditional tree graph. But if you have this multidimensional fold, like a construction could be, you can probably do many great things that work for both directions. And I will not go into details here, but I did work out a prototype showing a proof of concept that a constructional approach would be able to do that. Now I'm going to end in a minute, just to say that while we go back and forth the whole time between different modes, so most of the time I'm a linguist and I will go and take utterances and constructions and work out in very detailed example how the construction should work. Next time I'm going to work more in a natural language processing perspective and think, how can I now scale this up rapidly? And so it is, of course, perfectly possible for natural language processing to combine construction grammar with, or this symbolic construction grammar formalism that we have, with neurostatistical models. So here, for this sentence, for example, global warming has probably resulted in rising sea levels. I already asked, for example, I coupled FCG to a language technology called Spacey. Spacey can allow you to do dependency parsing and tokenization, part of speech tagging. That information we can populate our initial structures with. For English, I also use, for example, the Berkeley neural parser that gives me so this basically gives me like this dependency tree. The Berkeley neural parser already gives me some kind of tree structure, phrase structure grammar that I then combine in one structure, and then constructions can actually be like an added layer on top of that to extract more information. And here, the example that I have here is work that we've been doing lately. Is called semantic frame extraction. We're interested, for example, in extracting a bit more semantic information from sentences. So in this sentence, what we want to extract is a causal frame, where we want to know that global warming is a cause and rising sea levels is an effect of that. And using lexical databases like FrameNets, which are easy to translate into constructions because both are using feature structures, we can identify that a phrase like result in all of its many occurrences is like frame evoking elements, global, and then use the grammar to figure out what the relations are, relying on stuff that the neural statistical parser already gives us. Meaning that if everything goes well, we figure out the effect is rising sea levels. In this case, it's failed. Let me try another sentence to see if that works better. Rapidly falling costs of renewables. The effect is the growth. So that's currently ongoing work that we're doing for English, French, Dutch, Spanish, Italian, which should all be released, at least for English and Italian, already this year, but every year we'll have a new release. And this kind of interaction we also do with then actually robots that have to perform everyday tasks of cooking. And again, construction grammar is a very good way of, without having to build a generative system, to have a construction that goes from a instruction to the meaning. If you tell a cooking robot that it has to bake 2 eggs, well, it has to translate an utterance into sensory motor instructions. Constructions can easily map from syntactic constraints to instructions for a robot. And vice versa, if the robot would have to explain something to the human, you can take the instructions or the body model as the meaning space and then attach forms to that and produce sentences that the human would comprehend. Yes. So I will stop here so there is time for questions.
Thank you very much, Remy.